Here, we're going to look at special factoring formulas. Our first special factoring formula is when we have the difference of two perfect squares. Here we have a binomial that's subtraction instead of addition, and if the first and second term are perfect squares, we know that it will factor into the product of two conjugate binomials, such that the first term of these conjugate binomials is the square root of the first term of our original expression, and the second term of the conjugate binomials is equal to the square root of the second term from our original expression. Let's try an example. In this example, we have a binomial. It's a quadratic binomial, and we're subtracting, just as we see above. We know that 25x squared is a perfect square. As a matter of fact, it's equal to 5x all squared, because if you square 5x, you get 25x squared. 9 is equal to 3 squared. So now we can recognize that we have the difference of two perfect squares. If we have the difference of two perfect squares, it factors into the product of these two conjugate binomials. So 25x squared minus 9 is equal to 5x plus 3 times 5x minus 3. Here we have another example. It's the difference of two terms. The first term is the perfect square. 6 times 6 is 36, so 6 squared is 36, and x squared squared is x to the fourth. In other words, if you multiply x squared times x squared, you get x to the fourth. So 36x to the fourth is a perfect square of 6x squared. 16 is also a perfect square. It's equal to 4 squared. So we know that 36x to the fourth minus 16 will factor into the product of two conjugate binomials. 6x squared plus 4 times 6x squared minus 4. Our next special formula is the sum of two perfect cubes. The sum of two perfect cubes always factors into a binomial times a trinomial in this form. Let's try an example. Here's our example, the sum of two perfect cubes. 8 is 2 cubed, and x cubed is x all cubed. So if we take 2x and we cube it, we get 8x cubed. 27 is 3 cubed. So this will factor into the cube root of 8x cubed, which is 2x, plus the cube root of 27, which is 3, times the cube root of 8x cubed, which is 2x, squared. And if you square 2x, we get a 4x squared minus a times b. Notice that our a and our b are the cube root of a cubed and b cubed. So a is 2x and b is 3. So this is minus a times b. A is 2x, b is 3. 2x times 3 is 6x, so 6x goes right here. Plus b squared. b is 3. 3 squared is 9. So we've factored this equation. Let's move this up. Our next special formula is the difference of two perfect cubes. It's equal to the product of the difference of the cube root of the first and second term, which is a binomial, times a trinomial, as you see here. Notice that the sum of two cubes, it factors in a similar way that the difference of two cubes. The difference is our operators, subtraction and addition. Let's try an example. This time, let's see, 5 times 5 is 25 times 5 is 125. So we'll say 125 x to the 6 minus 4 times 4 is 16 times 4 is 64. So what I have is the difference of two cubes. My first cube is 5x squared all cubed. Because if 5 cubed is 125 and x squared cubed is x to the 6. And this is minus, and 64 is 4 cubed. Put a cube here. Now let's just remind ourselves, in our previous example, our a was 2x and our b was 3. That was the cube root of these two terms. Here, our a is 5x squared and our b is 4, because these are the cube roots of the first and the second term. Using the formula right here, which is how to factor the difference of two perfect cubes, we get the following. This difference of two cubes is equal to the difference of a, which is 5x squared, minus b, which is 4. And for the last polynomial fact, which is a 3-termed polynomial, which is a trinomial, we want to square a, and a is 5x squared. So if you square 5, it's 25, and if you square x squared, that's x to the 4th, plus a times b, which is 5x squared times 4. 5 times 4 is 20, so this is 20x squared, plus b squared, and b is 4. 4 squared is 16. So here we have factored the difference of two squares so that that is equal to a binomial times a trinomial.